Hello everybody. In this video we will discuss about aldehyde and ketone nomenclature and some of the basic introductions about aldehyde and ketone for these chapters. So what are aldehydes and ketones? Well, aldehydes and ketone has exact same functional group, that is carbonyl group CO, and we know carbon can make 4 bonds. So that's now we got carbon has 4 bonds. And aldehyde is when on one side you got your hydrogens, so that's gonna be your aldehyde. And if on the both side you got carbon chain, then that would be your ketone. So this is your ketone and this is your aldehyde. The only difference is aldehyde has hydrogen on one side. Other side could be hydrogen too. If the other side is hydrogen, that's the smallest aldehyde possible. But as long as you have one on one side an aldehyde, that's your one side you have hydrogen, that's your aldehyde. Okay, so one key characteristics. So aldehyde and ketone, they both react exact same way, almost identical. Their reactivity may differ slightly, but they react almost exactly the same way. So you don't need to learn multiple different type of reactions. You can easily exchange the reaction of aldehyde with ketones. Okay. So next key characteristics of aldehyde and ketone. Do they make hydrogen bond? Question number 1. Do they make hydrogen bond? So remember, you can only make, do they make hydrogen bond with themselves? That should be the questions, like with within itself. Well, they cannot make hydrogen bond with themselves because the oxygen does not have any hydrogen to begin with, so they're not gonna make any hydrogen bond with themselves. But because they have oxygen, they can make hydrogen bond with water or any protic solvents. They can make hydrogen bond if you have other protons, but they're not gonna do it with themselves. Okay. What kind of intermolecular force exists in aldehyde or ketone? Well, the intermolecular force that exists in aldehyde and ketone is your dipole-dipole interactions. Okay, so the intermolecular force that exists in aldehyde and ketones are dipole-dipole interactions, which is much stronger than normal van der Waals or London dispersions intermolecular force, right? Dipole-dipole interaction. So comparatively, these molecules are going to have higher boiling point than a normal alkane or alkenes, but they're going to have lower boiling point or melting point in comparison to alcohol. Okay, so they do have polarity because if you noticed, oxygen is more electronegative, so it would have a delta negative, which means carbon's going to have delta positive. Same here, oxygen is going to be delta negative, and here it's going to be delta positive. Okay, and next key characteristics that you want to focus is the structure. So these are sp2 hybridized carbon atoms, right? sp2 hybridized carbon atoms. So this is, both of these are sp2 hybridized carbon atoms. So what is the structure of sp2? So if it is sp2 hybridized, that means the geometry is trigonal planar. So the geometry is trigonal planar, just like your alkene. So same here, it's going to be trigonal planar. Okay, like we can draw a picture. So you have a plane and you can have your carbonyl in the plane of paper. And this is kind of important because when later you learn reactions, the attack of nucleophile on this particular bond. So nucleophile could approach from the top or it could approach from the bottom. So that's a major stereochemistry stereochemical implications on this one. So your nucleophile can approach from either sides. Okay, so enough of this discussions. Let's move on to the nomenclatures. Okay, so both aldehyde and ketone, it's very simple. Okay, find the longest chain containing the functional group. So you have to include the functional group. Longest chain with the functional group. In this case, you gotta include the aldehyde or you gotta include the ketone. Longest chain with the functional group. Okay, so let's go over. So let's draw a simple one like this. So let's say you got this. I'm showing you hydrogen. You don't need to show the hydrogens. So this one is an aldehyde functional group because on one side you got aldehyde. So the longest chain containing the aldehyde is 1, 2, 3, 4. Okay, so we got 4 carbon atoms. So that's our longest chains. Okay, so this is our longest chains. So you're going to include the aldehyde carbon atoms. So we got 4 of them. 1, 2, 3, 4 carbon atoms. All right. So then 4 carbon atom. So replace the E of alkane. Remember, all the name we write is derivative of alkane. So replace the E of alkane with L. So the E is replaced by L. So in this case, we got 4 carbon atom. So 4 carbon atom means butane. And then E is going to be replaced as L, butanol. Okay, so that's how you name them. What if we have a substituents and then you add the substituent? So let's say we got a substituents right there. So substituent is, then you follow the substituents accordingly. So substituent in this case is 1 carbon atoms, right? So that's going to be methyl. Remember how we name the substituent? You write the number of carbon atom, methane, and then methane, yeah. And then you replace the A and E with YL, methyl, 1 carbon atom. So it's, where is the location number? You gotta number the carbon atom so that your aldehydes get the lowest possible number, okay? So number the carbon atoms. So the aldehyde gets the smallest number. Okay, because aldehyde, the functional group gets the higher priority. So in this case, you cannot name other way 1, 2, 3, 4. If you do that, your aldehyde functional group is on the location 4. So that's the wrong way. So you get a number right to left for this particular example. So the actual name would be 3-methyl butanol. Okay, you don't need to put 1 there because can only be 1 butanol. You cannot have 2 because if it's on the 2, then it's not anymore aldehyde. It's gonna be ketone. So you will see it see it in a second. So what if I have the similar molecule and what if I had the similar molecule and I will have this. Okay, so find the longest chain containing the functional group. In this case, the functional group is going to be ketone. So the longest chain that contains the functional group ketone is going to be this. And how many carbon atoms we have in this? 1, 2, 3, 4 carbon atom. So 4 carbon atom means butane. Okay, so here in ketone, so this is a ketone. In ketone, E is replaced by on. Okay, so butane is gonna be butanone. That's gonna be your parent. So that's your parent. And what is the substituent? Substituent is the same as before, methyl. Okay, so our name would be 3-methyl butanone. Okay, again, 3-methyl butanone. You don't need to put the number 2. It's obviously there's the only one locations there can be 2. But if you have pentanone, so let's say I change these questions to something different. So let's say I change these questions, because there can be only butanone can only be at the location 2. So you cannot have 1 butanone or 3 butanone. Okay. So what if this now we got 5 carbon atom, right? So you gotta find the longest chain containing the functional group. So we got ourselves 5 carbon atom, 1, 2, 3, 4, 5. So 5 carbon atom means, so let me delete this, everything. So we got 5 carbon atoms. So 5 carbon atom means pentane. So E is replaced by on, so it's gonna be pentanone. That's your parent. Now where exactly your ketone group is, now you have to define the number. Okay, so here it's at the location 2, so it's gonna be 2-pentanone. So and the number is gonna be, substituents is 3-methyl. So it's gonna be 3-methyl 2-pentanone. Okay. So you can write this as pentan 2-on. For this particular compound, I don't think you can have any other number for ketone. So 2-pentanone, there can be only one. I think if we delete this one with the 2, should be okay, because there can be only one compound with this structures. I don't think you can have anywhere else. Would have been a lot easier if I just put because I add this methyl group. By adding this methyl group, I could not have anywhere else ketone. Okay, so let's make it slightly different. So what if you had 2 functional group? What if you had 2 functional group like this one? So here the rule applies the same as well. So there is a priority. There is a priority who gets higher priority when you have multiple functional group. Okay. So the higher priority is aldehyde always get higher priority than ketone. So far we have learned only 3 functional group, right? So aldehyde, ketone, and alcohol. So aldehyde will get higher priority. So this is 1, 2, 3. And if all of these exist together, aldehyde will serve as a parent and everything else will be substituent. So the substituent name for ketone is called oxo. Substituent name for alcohol is called hydroxy. there is something higher priority than aldehyde exist when we talk about carboxylic acid. So if there is an aldehyde, the substituent name can also be called as oxo. Okay, so let's not worry about this one for now. So what would you name this one? So in this case, you have to include your parent with the aldehyde. So your parent must include the aldehyde. So how many carbon atoms we have here? 1, 2, 3, 4. So it's 4 carbon atom, butane. Then E is replaced by al, so it's gonna be butanol. We don't need to add number because there can be only one butanol. But if you add, I won't take points off there. And then substituent. So who is our substituent? Our substituent is OH. So when OH is serving as a substituent, it's not an alcohol functional group anymore. Well, it's not gonna be butanol. This would act as a substituent. So we're gonna call it hydroxy. And what is the location of hydroxy? 3. Again, I'm not serving as 2-hydroxy because aldehyde gets higher priority. Okay, so it's gonna be 3-hydroxy butanol. Okay, so I will do one last example. So what if you have both aldehyde and ketone? Okay, so what if you have this? The same rule applies. Find the longest chain containing the highest priority functional group, which is in this case aldehyde is going to be highest priority because you got aldehyde, you got ketone. Okay, so in this case it's going to be aldehyde. 2, 3, 4, 5. So 5 carbon atoms, so it's going to be pentane. Then the E would be replaced by L. So it's going to be pentanol. So that's your parent. And who is your substituent this time? Our substituent is a ketone. Ketone functional group is a substituent. So this is your substituent. So what is the name? When ketone is acting as a substituent, the name is oxo. So it's going to be oxo. What is the location of oxo? 3. We cannot number other way around, like you cannot do this way around because you gotta put the aldehyde, the highest priority functional group, the lowest possible number. Okay, so the actual name would be 3-oxo pentanol. Again, there can be only one pentanol because aldehyde has to be 1. Aldehyde cannot be in between. Okay, that's pretty much all about the aldehyde introductions and nomenclatures.